Hello friends, our today's lecture is based on the numerical part of simple stress and strain chapter. In our previous lecture we have seen some basic examples of the simple stress and strain to know the concept of stress and to know the concept of strain. Today we will solve some little bit difficult problems and we will try to find out different methods, different approaches to solve such numericals. Okay, so let us start with the first numerical. So I will read the numerical. Please note it down. A steel rod of 40 mm diameter and 2 meter long is subjected to pull of 80 kilonewton. A steel rod of 40 mm in diameter and 2 meter long is subjected to pull of 80 kilonewton. To what length a bar should be bored centrally so that the total extension will increase by 20% under same pull? To what length a bar should be bored centrally so that total extension will increase by 20% under same load? The bore being 20 mm diameter, take E is equal to 2 into 10 raised to 5 Newton per mm square. Newton per mm square. Okay, so first of all, I will write the given data. It is given in the numerical. So, given parameters. First is solid rod, diameter is 40 mm. Then the pull force is given, it is 80 kilonewton, means 80 into 10 raised to 3 Newton. Then bore diameter is 20 mm. Then Young's modulus is given 2 into 10 raised to 5 Newton per mm square. Okay, so now see, this is the steel rod, 2 meter length is the length of rod is 2 meter and diameter is 14. If a bore is there, a rod is having suppose central bore of 20 mm diameter, then what should be the length of the bore such that the total extension will increase only by 20%, not more than that. Okay. So when initially bar is solid bar, when the bore is inserted centrally to the bar, what should be the extension? And extension should not be more than 20%. Then what should be the length? That is the problem. Okay. To what length a bar should be bored centrally so that total extension will increase 20%. Will increase by 20% under same pull. So what we will do? First of all, we will calculate the extension in the rod under the pull 80 kilonewton when the rod is a solid rod. There is no bore. Then we will increase it by 20%. So that will be the extension after this bore. Okay. So we will increase it and we will find out the extension after this bore. And putting the again same extension in PL divided by A formula, we will calculate the length of this bore. We will calculate this length of bore. Okay. So step by step we will solve the numerical. So first of all, we will calculate the extension in the rod when the central hole was not there. First case. Okay. So when central hole was not there, we will calculate the extension. So for that, what is the formula for extension? dl is equal to PL divided by E. PL divided by E. So that is the formula for the extension. Where P is 80 kilonewton, length of the rod is 2 meter, A the diameter of rod, so area will be, it is 400 pi. 400 pi. Okay, now we have to calculate the change in length in rod in first case dl. So I will substitute all the values of this formula PL divided by E. So what is P? P is 80. So 18 into 10 raised to 3. See, here it is in kilonewton, I have converted into newton. Similarly, the length of rod is 2 meter, means in meter. So I will convert it into mm. Because all other values are in newton per mm square. This is 400 pi. This is also, as this is in mm, this will be also in mm square. 400 into pi. E value 2 into 10 raised to pi. E value is 2 into 10 raised to pi. If you calculate this, you will get 2 divided by pi. Now when the bore was not there centrally across the bar, the extension in the rod was 2 divided by pi. So now what will be the extension after the bore? Extension after the bore, it will be increased by 20%. So dl after extension will be 20% increase. So 20% increase means 1.2 times this value, 2 divided by pi. So this will become 2.4 divided by pi mm. Okay. Now, as per their statement, we have calculated the extension after bore. But as per our formula, if we want to calculate the extension after this bore, how will you calculate? Now see, this is the diagram of a bar when central hole was there at a distance L. So this remaining distance will become 2 minus L. This will become 2 minus L. So now this rod will be divided into 2 parts, where one part is completely solid and second part is hollow, having a central hole of 20 mm diameter at the center. Okay. So what will be the area of this reduced section? Or area of this section will be your 400 pi, because this is solid area. Now what will be the area of this reduced section? So area of this reduced section will be equal to 400 pi. See, when I have to calculate area across this section, so total area minus area of this hole. So total area is 400 pi minus area of this hole, means pi by 4 into 20 square. Pi by 4 into 20 square comes to 300 pi. Okay. Then again, when I have to calculate the elongation of this rod, total elongation of this rod. So elongation of this first part plus elongation of the second part. Name this as a 1 and 2. So elongation, total elongation dl after extension will be equal to dl1 plus dl2. So dl1 will be p1 l1 divided by a1 e plus p2 l2 divided by a2. So p is constant, p will remain same. P value is 80 km, it is not going to change. So only n will change. 80 into L1. What is L1? L1 will be 2 minus 1. L1 is 2 minus 10. Area, here it is 400 and E 2 into 10 raised to 5. This is same. P again, L, and this 2 is in meters, so we have to convert into mm. 80 is in kilonewtons, we have to convert into Newton. You have to multiply it by 10 raised to 3. So now this for second case, P is 80 kilonewton. Then length is L. Here अपन length L consider किए so L. L2 is L. A2 we have calculated 300 pi into 2 into 10 raised to 2. And the real dash we have calculated here as per the statement of the numerical is 2.4 pi. 2.4 divided by pi. If you solve this, you will get the value of L as 1.2 meters. This is what they have asked in the numerical. To what length a bore, a central bore can be inserted across the solid bar so that the extension in the rod will increase by 20%. Will increase by 20%. See, so if you put a central hole up to length 1.2 meter, you will get the extension will be increased by 20%, that is 2.4 pi. Okay, so this is the solution of one numerical. We will solve one more example based on this simple stress and strain again. So we will read this numerical. A bar ABCD 950 mm is made up of three parts AB, BC and CD of length 250 meter, 450 meter and 250 meter respectively. The bar is there, length of rod is 950 meter and it has three parts AB, BC and CD. Length of AB is 250 meter, length of BC is 450 meter and length of CD is again 250 meter. AB and CD are cylindrical having diameters 25 mm and 15. AB and CD having cylindrical cross sectional area and its diameter is 25 mm and 15 mm. The rod BC is square section of cross section 30 mm by 30 mm. The rod is subjected to pull of 26,000 Newton. The rod is subjected to pull of 26,000 Newton. Find the stress in three parts of rod and find the extension in the rod, total extension. Okay. So I will draw this gauge and we will solve. Okay, so this is the sketch of problem. The bar is A, B, C, D bar. Three parts. AB part length 250 meter. BC is having length 450 meter. CD is having length 250 meter. Okay. So now this is cylindrical 25 mm diameter. This is square 30 mm by 30 mm, and this is cylindrical 25 mm diameter. Now we have to calculate stress in each part, and all these are subjected to a force of 26,000 Newton, means 26 kilonewton. 26 kilonewton. Okay. So we will take one by one part and we will calculate stress as well as elongation. First we will take part AB part, and we will first calculate stress in AB part. It is force divided by area. Force is 26 divided by area. Area, now this is cylindrical part, so cylinder area cross section pi by 4 into 25 square, because 25 is the diameter of AB section. So this will give you the value 52.97 Newton per mm square. And what is the elongation over this part? AB, again PL upon E. So what is P? P is 2600, L is 250. Area is pi by 4 into 25 square. E is 2 into 10 raised to 5. They have given this value of E. So this is 0.0662 Newton per mm. So this is for part AB. Then part BC. Now in part BC, again you have to calculate stress, force divided by area. Force is 2600. Length of, you have to calculate stress. Now the cross section of BC part is square section. So it is 30, area will be 30 by 30. Area will be 30 by 30. So if you calculate this, you will get stress 28.89 Newton per mm square. Then if you calculate DL, so this will be PL divided by E, 26000, L is 450 divided by area 30 by 30 into 2 into 10 raised to 5. You will get this value as 0.0652. Okay. Similarly, if you calculate for this third part, so you will get sigma is equal to P by same formula, P 26000, and area is now this cylindrical again, so pi by 4 into 15 square. So this is equal to 147.13 Newton per mm square. Similarly, this is part C. DL, PL upon E. E is going to remain same. Length is now 250. Area is pi by 4, 15 square into 2 into 10 raised to 5. You will get this value as 0.189. All these values of deformations are in mm. Are in mm. So total deformation of whole rod, complete rod चा deformation तुम्हाला calculate करायचे. So this dl plus dl plus dl. All these are extensions, so you have to just add all these values. So 0.0662 plus 0.0650 plus 0.189. So total will be 0.3155 41 mm. Okay. So this is how you can calculate the elongation, the extension as well as stress in the rod when the rod is of heading section. Now this rod is of heading section. This section is very different. This is different. This is different. Okay. So I will stop here. In next lecture we will solve some more examples on the stress strain chapter. Thank you.